Listo. Good morning, everybody. We are enjoy a beautiful speech about the growing need for catching container images in Kubernetes. The speaker for this speech is Senthil Rajan, and we will start with the video that the Senthil sent us. And here is. Play, please.
Called as the growing. My name is Senthil and I am from India, and I am hoping that you are having a wonderful day with KCD Guatemala 2021. And I am very glad and excited that I am able to talk to you about an important topic which is called as the growing need for caching container images in Kubernetes. So this talk is all about why we are seeing an increased number of use cases which requires caching container images in Kubernetes, and I'll explain how to implement a caching solution using an open sourced project called as Cube-fledged. So let's get into the talk. My name is Senthil and I work as principal software engineer in Ericsson. My responsibilities in Ericsson is to architect and design cloud native AI/ML platforms. So these are platforms which are used for running machine learning models at scale in a highly distributed fashion. And my role is to use open source solutions as well as homegrown solutions to be able to run machine learning models across multiple platforms. And I am an organizer of KCD Chennai 2022, and this is coming up sometime next year. And we are gearing up to host the very first KCD in Chennai. And I'm the maintainer of the Cube-fledged open source project. So I'm going to talk more about the open source project in this talk. I spend quite a bit of time on tech blogging. So you can find me on Medium, and I post a lot of blogs around Kubernetes and cloud native technologies. And you can find me on Twitter as well. My Twitter handle is @SenthilRCH. And I'm a big fan of the Netflix series Money Heist. And by the way, season 5, volume 2 is launching on 3rd of December, so don't miss it. So the agenda for my talk today is this. So first we will cover what are the use cases for caching container images in Kubernetes cluster, and then an overview of Cube-fledged, the open source project that I'm going to talk about, which is used for caching container images in Kubernetes, its features and how it works, and I'll give you useful resources to continue your journey on caching container images. I'll talk about what's in store for Cube-fledged in the coming months and years. And I'll also briefly touch upon some similar projects which try to tackle the same problem with different approaches. And then we will go ahead with Q&A. Right. Now, let's talk about the use cases for caching container images in Kubernetes. For instance, you have a real-time application. For instance, it is processing some high-speed data, which is streaming data, right? And such applications require to start up very quickly. And even if they scale, for instance, if they scale horizontally and new instances of the pod have to be started up, and the scaling also has to happen in a rapid fashion. So we are increasingly seeing many such applications. For instance, in the machine learning world, there are lots of data processing applications which require a rapid startup and scaling. And second is in the cloud realm, serverless is gaining more traction day by day. And serverless functions, they need to react as quickly as possible to the incoming events, right? So when a new pod has to be started up, to serve the function, the pod has to start almost instantaneously. Only then you will be able to serve your functions. Only then the functions will be able to react to those events very quickly. And there are applications that run on edge environments, for instance IoT edge devices. These applications should be able to tolerate intermittent network connectivity. So there will be some fluctuations in the network connectivity, or there could be some fluctuations in the bandwidth available. So in which cases these applications will not be able to reach the external network, or they will not be able to reach the cloud. So in such cases also it is better to cache the container images on these edge devices or very close to those edge devices. And another interesting use case is from a security perspective. So if you are having a highly secure private image registry and you cannot grant access to pull images from this private registry, so one easy solution is you can make the specific container images available on the Kubernetes worker nodes itself, so that users will never have to pull the images from the container registry, right? So these are some of the typical use cases wherein it is always desirable to have some sort of a caching solution, so that you can make use of the container images that are directly available in the cache rather than pulling the images every time from the centralized image registry. Now moving on to Cube-fledged. So what is Cube-fledged? So let me give you an overview of what Cube-fledged is. It's basically a Kubernetes operator implemented using a custom resource definition as well as a controller. And the main purpose of Cube-fledged is to cache container images directly on the worker node. So you can actually define an image cache custom resource, and you can specify what are the images that you want to be part of the cache and onto which nodes those images have to be cached, and then the Cube-fledged controller will take care of the necessary steps for caching the images. And supported runtimes, it supports Docker, Containerd, and CRI-O. It supports 3 different methods of installation. So you can make use of plain vanilla YAML manifests, or you can use the Helm chart way of installing. And for advanced users who rely on operators, you can also make use of the Helm operator way of installing Cube-fledged. And Cube-fledged provides you with pre-built images for all the components in Cube-fledged. And another interesting advantage that you get is the pre-built images which are hosted in Docker Hub. These images are whitelisted from Docker Hub's rate limiting policy. So you can as well immediately start using Cube-fledged without worrying about Docker Hub's rate limiting policy. Now, what are the features of Cube-fledged? And as I said earlier, the main feature of Cube-fledged is to cache images, right? And there are 2 different ways of caching images that are supported in Cube-fledged. So first is either you can cache images to all the nodes in the cluster, right? Or you can define a subset of the nodes and you can specify that these certain images have to be cached only on those nodes. So you can use you can use node selectors to specify the subset of the nodes. And it supports refreshing the cache as well. So there is an automatic way of refreshing the cache, and there is also an on-demand way of refreshing the cache. So when you refresh a cache, what happens is Cube-fledged sees what are the images missing in the cache, and it will go and pull those images and download them into the cache. And whenever a new node is added to the Kubernetes cluster, and if you had enabled automatic cache refresh, so when the next cycle of cache refresh happens, these new nodes are automatically detected and the images are cached onto these new nodes. And not only caching images, kube-fledged also gives you the ability to modify the cache. So for instance, you can add new images into the cache, you can remove images from the cache, and you can also purge the image cache. For instance, if you decide that you don't want to cache the images anymore, so you can use the purge action to remove all the images in the cache, and you can also decide to remove the cache completely. And it supports both public and private registries, and the cache spec that you specify in the image cache custom resource, that is validated using a webhook admission controller. So it has two main components. One is the primary controller, which does all the job of pulling the images and deleting the images and things like that, and there is a webhook server that is bundled in kube-fledged as well, that takes care of validating the cache spec. So that's about the features of kube-fledged. And now, how kube-fledged works. So if you are interested to know more details on how exactly kube-fledged works, and this is the slide for you. So as I said earlier, there is a custom resource. There is a custom resource called as image cache, right? And this custom resource is actually exposed by the image cache CRD. And users will typically write an image cache manifest. So in this manifest, users can specify what images they want to be present in the cache, and they can also specify whether those images have to be cached in all the nodes or only to a subset of nodes. And if they want to pull images from private registries, it allows you to specify image pull secrets that has the credentials for those private registries. And once the user submits this image cache manifest to the Kubernetes API server, the next action that takes place is validation of the cache spec, right? And this validation is performed by the kube-fledged webhook server. You can see it there in the diagram. So it functions as an admission controller. So Kube API server will trigger a post a HTTP API call to the kube-fledged webhook server that is called as the validating webhook event, and then the webhook server performs the validation and returns back the validation result. And once the validation result is successful, the API server will persist the image cache CR in etcd, and the moment the persistence is done, the image cache worker, so you see a worker at the left side of the kube-fledged controller, and basically the kube-fledged controller is the primary component in kube-fledged that has various worker routines. For instance, there is an image cache worker, there is a refresh worker, and there is an image manager. So the image cache worker will actually respond to new image cache CRs or modifications to those image cache CRs, and then it will parse the manifest and then build image pull or delete requests, and it places those requests in a specific queue, and these requests are in turn watched by the image manager. The image manager will be polling the queue, and then image manager, once it sees there is a request in the queue, it opens up the request and then it finds that it's an image pull request, and then it prepares a Kubernetes job manifest and then submits a job to the Kubernetes API server, and then this job will subsequently be responsible for pulling the image from the image registry. And interestingly, the job actually delegates the image pulling action to the kubelet on the worker node. So there is no special component that is required to be run on the worker nodes for kube-fledged to pull the image, because the image is actually pulled by the kubelet running on the node. And once the jobs are successful, the image manager puts the result into another separate queue. The results are then read by the image cache worker, it's then aggregated, and then the final result is updated as a status. and then events are also generated so that you can have a complete understanding of what is going on with the image cache request, and you can also query the events later to understand what exactly was happening with your request. And there is a separate refresh worker which is responsible only for refreshing the cache. So it runs on a periodic basis, and this periodicity can be configured, and on a periodic basis it checks whether the image cache is up to date, and if at all it sees that some images are missing, for instance if those images have been garbage collected by Kubernetes, or if those images have been accidentally deleted, so whatever reasons, if the refresh worker feels that the image has to be pulled again, so it will trigger another request back to the queue, and then again image manager will get triggered, and then the cycle goes on. Okay, so that's pretty much how kube-fledged works, and it primarily consists of the kube-fledged controller and the kube-fledged webhook server. So let's move on. So if you want to learn further about kube-fledged, so if you are interested in the image cache image caching functionality, and if you want to implement image caching solution, so you can head on to the readme file of kube-fledged GitHub repository. Let me show you the repository. Yeah. Okay, here we go. Now this is a readme file of the project, and here you will find all information regarding how to use the component. So you'll have use cases, prerequisites, and I have documented all the 3 different ways of installing kube-fledged. And if you want to understand what are the parameters that are exposed by the Helm chart, you can take a look at it. And if you are interested in rebuilding kube-fledged yourself and deploying it, you can head on to these sections to understand how to build it and how to deploy it yourself. And there is extensive documentation on how to use it, what are the various image cache actions supported, and you can take a look at how it works and what are the various configuration flags. So all the documentation is available here. And if you want to get more details on the background of this idea and what was the initial thoughts and what was the initial design proposal, you can take a look at the design proposal document. And very recently, sorry, I shouldn't say very recently, it was almost 2 months back, and I wrote a tech blog describing in detail about image caching and what are the use cases for image caching and how kube-fledged helps in building an image caching solution. So you can find it on Medium. So this is the link for the blog. Now that you have an understanding of image caching in Kubernetes and how you can use kube-fledged to cache images, right? Now what's in store for the project? So how is the project going to evolve, right? So these are some of the items that we have in the roadmap. So we wanted to have the ability of building the image cache spec automatically from pod annotations. So rather than users having to specify upfront the description of the image cache spec, so we are planning to introduce an option which should allow the users to automatically build an image cache spec. For instance, if the cluster already has a set of images cached in these nodes, so you can have the ability of building an image cache spec out of the existing images. Or for instance, if you don't want to pick all the images in the cluster, you can also use annotations to specify whether the image for that pod has to be cached or not. So that's a very interesting use case, and hopefully we will be able to implement it in the near future. And another feature that we are contemplating is how we can optimize or bring in more efficiency in pulling images to the cache. So rather than pulling the images from each and every node, so we are thinking how we can optimize it by pulling it once from the image registry and then distributing it internally to the rest of the nodes. And we have plans for hosting kube-fledged in the operator hub. So operator hub is a centralized repository wherein you can find different types of operators, and hopefully we will be able to host kube-fledged in operator hub, so that users who consume Kubernetes native applications in the form of operators, they can easily discover kube-fledged, and they can very easily consume kube-fledged and start using it. And the fourth one that we have in mind is image adoption, and I briefly touched upon image adoption when I spoke about the very first point, that is image cache spec from pod annotations. So image adoption is basically if you have images already present in the cluster, and if you want to adopt those images into kube-fledged image cache. So we are planning to introduce features for that as well, so that once you adopt those images into a kube-fledged image cache, you can perform various operations. For instance, if you want to delete a certain image from all the nodes in the Kubernetes cluster, the moment these images are adopted into image cache, so it's very easy to do that. So you simply perform a remove operation, or sorry, you simply perform a purge operation, which will actually get rid of all the images in the all the images that you are targeting to remove. So that could be another interesting feature wherein kube-fledged will more evolve into an image management solution. So from which you can view, using which you can view, for instance, what are the images that are present in your cluster, what is the size of that image, when it was downloaded, who downloaded it, and if you want to get rid of some of the images, perhaps it will give you an estimate of what is the disk size that you will eventually be able to recover, and then you can selectively decide which images could have to be deleted. So image adoption is a key feature that can enable kube-fledged to evolve into one complete image management solution. But for the immediate future, the focus will be more on image caching and how we can make it more robust and how we can bring in more user-friendly features. But over a period of time, we definitely see image kube-fledged be getting evolved into an holistic image management solution for images in Kubernetes. Now, if you are interested to explore other options for solving the same problem, right? So here I have listed 3 similar open source projects. So these are projects that eventually try to solve the same problem of starting up and scaling containers very quickly, but using a different approach. Okay. So the first such project is StarGZ Snapshotter. This is actually an application that enables you to do lazy pulling on images. So it's an image distribution plugin which supports lazy pulling. So what is lazy pulling is, you have a container image and it has multiple layers, right? And lazy pulling is essentially it makes sure that what files are immediately required for the container application, those files alone will be pulled first, and then the container will be started up. So when the container starts up, it will start consuming the files that are already pulled, And in the meanwhile, in parallel, in the background, the other files of the container images will be pulled. So there will be some amount of parallelism happening, and this is what is called as lazy pulling. So if you are interested in such kind of solutions, you can use StarGZ Snapshotter. And another project is Kraken from Uber, and it actually employs P2P protocol. So what it does is basically it actually pulls the image from the Docker registry, and then it distributes those images from the very nearest node. So I don't think I have much time to enter into the details, but what happens eventually is, if you start a container and if the container image is not available in that particular worker node, what happens is the request is actually sent to a nearby agent which has that image, and then using P2P the image is actually sent to this node. Okay, so the mechanism here is little bit complex, and if you are very keen on trying out P2P based image distribution solution, so you can try Uber Kraken. And there is a third option which is called as Image Wolf. This is actually a POC, and it is not a workable solution that you can use in production. It uses BitTorrent protocol to distribute images, and it's not very active. So these are some of the options that you can leverage. And there is also a very recent announcement from Google Cloud, which is called as GKE image streaming. So image streaming, the approach is little bit different. So what happens in GKE image streaming is, basically when the container starts up, the initial files required for that container will be actually streamed over the network. So it will be streamed over the network. So probably like a network share. So when you mount a network share and then you consume the files from that network share, what eventually happens is the files will be streamed from the network server, from the NFS server. So very similar to that, but it is actually a very complex solution. So there is also a caching layer. There are multiple caching layers implemented in GKE image streaming, and and such features are actually targeted for very highly sophisticated environments and complex requirements. But for most of the use cases for caching images and for managing the images in the cache, Cube-fledged will be very useful, and it is a very lightweight solution. It doesn't runs any agent on the worker nodes, and it has a webhook server which performs the validation of the cache spec, and there are some cool user-friendly features that are in pipeline for Cube-fledged. So with that, we have reached the end of the presentation. So thank you so much for watching this talk. I hope you enjoyed the talk very much, and I really hope the Cube-fledged project will be useful to you. So if you have any further questions, feel free to reach out to me over email, or I can be easily found on Twitter, and I am fairly active on Twitter. So please feel free to connect with me on Twitter, and also don't forget to check out the Cube-fledged project in GitHub. And with that, I would like to thank the organizers of Kubernetes Community Days Guatemala for giving me this opportunity to talk about this topic. And I wish all the speakers and also the attendees a very excellent day, and I hope you get lots of useful information out of these 2 days of KCD Guatemala. So thank you so much, guys. Thank you for having me here. Have a wonderful day, and thank you so much. Bye-bye.
Thank you so much for this speech, Senthil. Um, we have here an interesting question, and it's about the cost the cost to pay with these kind of tools, because it is better, is faster. It will not be cheaper like the other options.
Okay, can you please repeat the question? I don't think I got the question correct. Can you please repeat the question?
Sure, sure. Is how affect these kind of tools the cost to pay when we are
Uh,
implementing? Mhm.
yeah, the cost of using Cube-fledged is basically you don't have to pay for any license because the Cube-fledged is an open source project that is available for usage using the Apache 2.0 license. It's a very liberal license, so you can as well use it in whatever way you want. So there is no cost involved in using Q-fledged for caching your images in Kubernetes. It's an open source project.
Thank you so much, Senthil. For about time, we only can pass you this question, and in this moment, we will thank you so much for this presentation. It's a very interesting tool, and thank you so much also for recommend those the other three tools or open source projects.
Yes,
Uh,
thank you so much for
I'm so
listening.
sorry, Sergio. Tell me that if you can pick another question.
Yes, yes, I am very much available. I can take any more questions.
Sure. Sergio, can you send us your question, please?
Do I have to check the chat to see if there are any
Yeah,
questions?
this. No, just if there is another. I'm so sorry. Is in this case, again, thank you so much, Anthil, for your presentation. It is so interesting, and we hope that this project will grow in, and we will use it on our implementation. Thank you so
Yes,
much.
thank you. Thank you so much to
Have a nice
everybody.
day.
Thank you for giving me this opportunity to meet you all. So hopefully you had enjoyed the talk and you can as well check out the project. And if you have any questions, post an issue in GitHub or reach out to me on Twitter or email. And if you are interested in contributing, there are lots of cool features, helpful things that you can do. So hopefully this will be able to, you will find Q-Pledged as a very useful project for kickstarting your open source contribution as well. So thank you so much, everybody. Have a nice day. Bye bye.
Yeah. Thank you, Sadhu, for your presentation. I think that it's really awesome to share with people with that is living in India and everything, sharing with people from Guatemala, the difference on time is really awesome how the technology connect you with the people in the other side of the world. So thank you very much for that.
Thank you. Thank you, Sergio. Thank you, everybody. Bye. Have a nice day.
I
Good.
think that
We're
Mexican
we're going to
nation,
pass the track number one for the next speaker.
yeah, for sure.